Welcome back, my gentle and modern apes, to the Gutsick Gibbon YouTube channel, where we go over anthropology, paleontology, primatology, and evolutionary biology, as well as occasionally busting some pseudoscience when we do get the opportunity. I also come to you now, sharper visually and in an auditory sense than ever, thanks to the beyond generous donation of a brand new webcam and a brand new mic system from Darren, the Quiet Gorilla, an excellent viewer of mine and a pal. I appreciate it more than you can ever know, Darren. Thank you so much, and I'm sure the audience appreciates it as well, now that you can hear my nasally voice in unbridled glory. Now, I know some of you may have been expecting a different video today. Perhaps you were anticipating a continuation of our Library of Errors, which will be coming soon. Or perhaps you were expecting my In the Works video towards the brain trust with regard to some recent claims on the Y chromosome and some community posts that have been bopping around. But in the meantime, as I do indeed like to take my time with those kinds of systematic bustings, I figured I would bring to you a video on Homo floresiensis, one of our more diminutive and enigmatic relatives. You also may notice that we are in a new location. You'll see familiar faces. Of course, Caesar is still here, our Australopithecus afarensis skull, the Smilodon, our bemolared Smilodon for that matter, our Dunkleosteus, the usual suspects. But I have finally moved back out of my parents' house. I'm no longer paying my rent on my old flat in London. It's so sad. I wish I was still over there, but you know how pandemics be. Before we launch into Homo floresiensis, I'd like to also preface my new opener. This new opener is fully animated by me, by hand. It's a couple thousand frames, so appreciate it. It's a bit long. If you prefer the long version, let me know in the comments. If not, I do plan on shortening it a bit. This was just something that I wanted to do. It's an animation project that's been on my mind for quite some time. I figured why not put it into an opener, a stylized opener to give to my lovely viewers. But I felt that it was a necessary animation to make because the tale of human evolution truly is grand in scale to me. So this is my homage to the entire process that led our species to where it is today. I hope you enjoy it.
See how the surf's work the ground. And they give it all they've got. And they give it all they've got. And you give it all you've got till you're down. See how the brain plays around. And you fall inside a hole you couldn't see. And you fall inside a hole inside of someone. Help me understand what's going on inside my mind. Doctor, I can't tell if I'm not
Deep in the jungles of the Indonesian island of Flores some 38,000 to 74,000 years ago, small figures flitted through the mists among the dwarf elephants. These diminutive primates would throw a monkey wrench into what was once thought to be a very consistent trend in human evolution, but their eventual place in the human family tree would be surprising. The year is 2001. The pre-9/11 carefree United States was releasing cinematic hits like gangbusters, from the first Lord of the Rings and the first Harry Potter, to Monsters, Inc., that one Planet of the Apes that ended with Abraham Lincoln, and of course, Morwood and collaborators were leading a team from the Indonesian Center of Archaeology in Jakarta and were investigating a cave site known as the Liang Bua off the island of Flores near Java. Up until this point in time, only modern humans were thought to have been capable of making their way across Southeast Asia onward to Australia and to New Guinea. Morwood, though, was not convinced. Gathering his team, the group decided on Liang Bua Cave, and upon investigating several large trenches within the maw of the site, they stumbled across stegodon remains along with some stone tools. Someone had been hunting these pygmy proboscideans. But in the year 2003, Liang Bua would yield something rather shocking. The remains of a small-bodied hominin, some 3.5 feet tall, that looked incredibly human. So human, in fact, that initially the researchers thought that it was just a human, as in anatomically modern, or perhaps archaic, but certainly Homo sapiens, child. But upon closer investigation, the skull, dubbed LB1, was found to contain wisdom teeth and a heavy brow ridge. It was definitely an adult. 1 year later, in 2004, Morwood rather boldly proposed that the creature was a member of a brand new species known as Homo floresiensis, a claim that to many paleoanthropologists felt like a jump of the gun. Morwood et al. Justified their claim by pointing out that the nearest species found to Homo floresiensis, Homo erectus to the north, lacked many of the characteristics that made this new species unique, from the humeral torsion to the nature of the ulna. Homo floresiensis did not match up with what would be expected for an allometrically smaller member of Homo erectus. Alternative hypotheses were quick to pop up. Jacob et al. In 2006 would jump at the opportunity to analyze the specimen, and using osteological data and skeletal scans, they would determine that the characteristics of LB1 were within the range of developmentally pathologic regional variants of Homo sapiens. They pointed specifically to the Rampasasa pygmies, who lived near Liang Bua today, and display some of the more basal characteristics of Homo floresiensis, as well as the asymmetry of the face that appeared to be pathologic and potentially microcephalic brain case. But prior to the release of that paper back in 2005, Falk et al. Compared the endocasts, or brain molds, of Homo floresiensis to those of modern humans, a microcephalic human, a pygmy, Homo erectus, Australopithecus afarensis, and Paranthropus aethiopicus. They noted that in brain-to-body ratio, Homo floresiensis was a dead ringer for an Australopithecine, but in endocast shape, it leaned more towards Homo erectus. They also pointed out that the frontal and temporal lobes of the LB1 endocast revealed derived grooves associated with higher cognitive processing. After this paper came out, though, the team came under heavy fire for some of their methodology. Critics primarily took issue with the extrapolations Falk and company took with their endocasts, essentially pointing out that the endocast wasn't enough to make claims about the proportions of the brain. So Falk, properly irritated, said, "Okay, how about I do another study then?" In their new study, Falk et al. In 2007 tackled both their critics and the results of Jacob and collaborators. In a stunning display of rigor and maybe a bit of overkill, they performed a comparative analysis of 10 healthy, modern, and decidedly human women, 9 modern microcephalic human women, 1 human woman with dwarfism, and LB1. The full analysis grouped LB1 with the healthy women in one group and the rest of the pathologic women in a separate group. This analysis supported once more that LB1, and indeed the species of Homo floresiensis, was not a degenerated member of Homo sapiens. But what about perhaps a degenerate or pygmy form of Homo erectus? Argue et al. In 2017 would determine that this was statistically nearly impossible based on their use of parsimony and a Bayesian phylogenetic method. Quote, "The new data and analyses support the hypothesis that Homo floresiensis is an early Homo lineage. Homo floresiensis is sister to either Homo habilis alone or to a clade containing at least Homo habilis, Homo erectus, Homo ergaster, and Homo sapiens. A close phylogenetic relationship between Homo floresiensis and Homo erectus or Homo sapiens can be rejected. Furthermore, most traits separating Homo floresiensis from Homo sapiens are not readily attributable to pathology, e.g., Down syndrome. The results suggest that Homo floresiensis is a long-surviving relict of an early hominin lineage and a hitherto unknown migration out of Africa, and not a recent derivative of either Homo erectus or Homo sapiens." Unquote. This confirmed the results of an earlier study from 2009 that placed Homo floresiensis either in slightly more or slightly less derived position than Homo habilis based off of 60 cranial, dental, and postcranial features. When examining the postcrania, the same results come to light. The wrist displays the traits known to be diagnostic of the African apes and humans clade, according to a 2007 study done by Tocheri et al. An entire analysis of the locomotion pattern from Younger's 2009 came to the conclusion that Homo floresiensis is decidedly mosaic in its upper limb bones and contains a combination of basal and derived traits never seen in modern humans. Brown and Maida in 2009 came to the same conclusion when analyzing the mandibular and dental traits. So needless to say, the pathology hypothesis has been punted for quite some time, and fairly rigorously so. But questions still remained. Why exactly was Homo floresiensis, this diminutive branch of the hominin family tree, so very small? And furthermore, how did an organism with a brain that was not that much more substantial than that of a common chimpanzee today manage to make it to the island of Flores? Homo floresiensis had already been a shocker in its size. It seemed to fly in the face of the consistent trends seen thus far in human evolution, that hominins had been getting exclusively bigger in both stature and in brain case size. This species reminded paleoanthropologists that our relatives, like all animals, could be subject to the changing world around them. We were always simply selective pressures away from losing our most valued traits should they cease to be worth the metabolic cost in a given environmental condition. We know Homo floresiensis is descended either from early Homo habilis, another known hominin, or an unknown member of early genus Homo. Some have suggested a more derived Australopithecine may also be responsible. This is supported by the above literature as well as the series of traits unique to Homo floresiensis alone. Homo habilis is known to be considerably larger than the remains of now 9 identifiable individual members of Homo floresiensis. This suggests that we are dealing with a species that has undergone some degree of island dwarfism. In the case of Homo floresiensis, this is known as the isolation hypothesis. Island conditions are known to warp organisms in bizarre ways due to their impact on the resources that populations that find themselves on the island require to survive. Natural selection may take a population whose ancestors were large and shrink them due to a lack of sufficient resources or perhaps the presence of less energy-rich foods. This means that animals require less metabolically will thrive when compared to animals that require more. Thus, there is a selection to grow smaller. Such was evidently the case with Stegodon, the so-called pygmy elephants found alongside Homo floresiensis, as well as the pygmy hippopotami once found on the island of Madagascar and the pygmy caprids on the island of Mallorca. But the opposite can happen as well. Flores was once home to giant rats, giant storks, and enormous monitor lizards, not unlike what we see today on Komodo Island. In this case, organisms that were ancestrally small are exposed to more resources and perhaps fewer predators, giving them the opportunity to grow in size if competition selects for it. After all, growing large is never the best bet unless it is beneficial for an organism's reproductive potential. These are the key concepts that tie into the optimal body size theory, which essentially says the above. There is an optimal body size that will be selected for when taking into account the variables of reproduction, food acquisition, competition, and predation. So we have an explanation for our small-bodied hominin, bolstered by applying the OST analysis to potential ancestors of Homo floresiensis, as well as the presence of other shrunken and inflated fauna on the island of Flores. But now we have to get our little primates there. Looking at a map of the Malayan archipelago, one wonders how a species like Homo floresiensis could have gotten to the island of Flores, as there are indeed many straits. Some have suggested that we need to rethink our notions of how intelligent Homo floresiensis truly was, positing that maybe we had a little sailor on our hands. Personally, I think this is just an excuse to imagine these little guys in miniature sailor suits.
Look at the top of his head!
My reason for positing this primarily has to do with the fact that the stone tools we find associated with Homo floresiensis at Liang-Bois are rather sophisticated, but not so much so as to suggest sea navigation. I think the far more likely hypothesis is that the species rafted there unintentionally. This may seem unlikely, but remember that according to Diamond in 2004, the timeline sees our stegodons making it to Flores, Timor, and Celebes without intentional rafting. Until we see some support for the cognitive abilities of Homo floresiensis meeting the requirements of seafaring and navigation, I think entertaining the rafting hypothesis is more likely. Homo floresiensis would have lived a wildly tumultuous life on the island of Flores, hunting the stegodons and fleeing the hungry dragons that roamed the land in search of tasty hominins. Giant rats and, of course, giant storks occupied the land as well, but eventually some taller and more intimidating hominins would arrive and the presence of Homo floresiensis would wane until they disappeared from the island and faded into memory. We see this in the succession of remains at Liang-Bois Cave, with these small-bodied hobbits being slowly but surely overtaken and replaced by the larger-bodied hominins known as Homo sapiens. No one truly knows exactly how long the members of Homo floresiensis managed to persist with our relatives kind of infecting the entire island. But the youngest remains of Homo floresiensis that we find at Liang-Bois date to around 50,000 years of age. Given the nature of taphonomy, it's possible, if not likely, that they did manage to persist at least sometime after that point. Support for this right now is highly circumstantial, but potentially exists in the stories of the local cultures itself. The Ibu Gogo is a cryptid that appears in the Flores Indonesian lore, much like Bigfoot in the United States. They reportedly had wide, flat noses, broad faces with large mouths, and hairy bodies. The females are also described as having long and pendulous breasts. They were said to have murmured in what was assumed to be their own language and could reportedly repeat what was said back to them in a parrot-like fashion. Some Flores people groups claim that they once roamed the island but can no longer be found there today. In the Nage language of Central Flores, Ibu means grandmother and Gogo means one who eats anything. Anthropologist Gregory Forth, professor of anthropology at the University of Alberta, Canada, has stated that the wild man myths are prevalent in Southeast Asia and has investigated their linguistic and ritual roots, speculating that Homo floresiensis may be evidence that the folk tales of Ibu Gogo and similar creatures such as the orang pendek on Sumatra may in fact be cultural memories rooted in fact.
All in all, Homo floresiensis is a fascinating hominin with a rich and ever-growing fossil record. Perhaps one day we will uncover more of these small-bodied hominins, whose memories still echo in the humid jungles of yesterday.
I'm Erica, and this is Gutsick Gibbon. I'll see you next time.